Ekonomu. On behalf of the Clinton Climate Initiative and partners in Project Green, I would like to welcome you to our third monthly series of green technology webinars. Today we are featuring 3M window films. Just before we start the presentation, I would like to go over a few points. Please do know that your phone will be muted throughout the entire webinar. If you have any questions, please type them in the chat section located to the bottom right corner of your screen, and I will read them out during the presentation or Q&A session. Also, if you would like to know more about 3M window films after the presentation, or if you are interested in finding out more about the product discounts that are provided through the Clinton Climate Initiative, please contact myself directly. Let's begin. So I would like to introduce Jim Mannix, National Accounts Manager for 3M Window Films. He is joining us from St. Paul, Minnesota this afternoon. Jim, now if you press star 7, that'd be great so everyone can hear you.
Good afternoon.
There
Everybody
you go.
hear me?
Yes.
I guess you're muted, so you can.
Yes, we can. I can hear you. Yes,
right?
yes. And if anyone has any issues, just please type them in the chat section towards the bottom right hand corner.
Well, good afternoon. I appreciate your interest and attention here, and I will walk you through the paces a little bit on what 3M window films are and where we've come from and where we are today. See if I get this thing to work. Oh, the logo didn't come through. That's 3M there. 3M itself has been around since 1902. We're a $26 billion company. We have the original patent on window film, and we're in over 60 countries with our window films and continually working on innovation to bring out new products, especially in the window film area, that are going to focus on what's of keen interest to people now with energy being top of mind, energy reduction, trying to achieve maybe some lead points or Energy Star, or just a more stronger building environment. All right. So I just want to walk you through. We make a variety of different window films: sound control, safety and security, decorative and privacy. The focus of this presentation is primarily going to be on our sound control or energy control films. And then we'll give you some case histories to kind of put some shape to this. Let's see if I can get this thing to work. There you go. As I said, we've been doing this for over 45 years with the original patent. Back then, you can get any color you wanted as long as you picked silver. That was the original film. Basically, it's a thin microscopic film or coated with a thin layer of metal. And I'm going to give you why people use these films. And it's primarily today it's kind of comfort and energy savings. And I would say it used to be all about kind of comfort or balancing the building. And if there were savings, that would help justify the purchase. Energy and the cost of energy going up and utility rebates out there making energy a keener focus and a stronger compelling reason for making the investment in window film. And one of the things that we like to stress here is it's a passive application in the sense that once it's there, there's nothing that has to be run or plugged in. It's working for 24/7 on your windows, working for the building. But besides energy and occupant comfort, it does help mitigate some glare issues because we block out ultraviolet as well as some visible light and heat. It can help protect things from premature fading. There is a safety element, and also you can help improve or not improve or not change the building aesthetics depending on the type of film you go with. I mentioned there's three kinds of films that we make, and then some, but the focus here is going to be on sun control, focusing on better energy management in a commercial environment. There's generally a couple of types of films. A metallized film, which I mentioned initially, is where you take a thin layer of polyester and then coat it with a microscopic thin layer of metal. The original film was aluminum, so it gave you that silver look. It worked very well in terms of reducing the cellular load, but still maintaining the function window where you could have vision to the outside. We've come a long way, and different metals can give you different looks. I mean, people are using today silver, aluminum, copper, nickel, all for different performances as well as different appearances. Over the years, people have asked us, since we started this business, and big player in it, can't you give us a film that's virtually clear and does the same thing, knocks out the heat? And our latest technology in the last few years can do just that. It's what we call our Prestige series. It is a non-metallized window film. And what it is, it really uses a lot of our technology that we use in LCD films that you see on laptops and PDAs. It's a film that's between 200 and 300 nanolayers of film. And each layer is blocking different wavelengths of light. So with our Prestige series, we can knock out as much as 95% of the infrared light, which is not your total heat. There's still greater than 40% that comes through in the visible spectrum. But by knocking out the majority or most of the infrared heat, we can leave it more open in the visible, which brings in more of the natural daylight, which is important today as well. So it's a virtually clear film, and this will give you a little demonstration, through a webinar anyhow. This is a side-by-side panel with an infrared lamp, and the film is actually on the left side of that light divider. And these are it's actually the same BTU meter. And as you look, you can see on the right where it's just clear quarter-inch glass. It's got over 246 BTUs. And on the left side, same lamp, it's got 34 BTUs. It's measuring the reduction in the infrared, which is quite significant. And yet, as you can tell, hopefully you can tell by the side-by-side comparison, they're virtually identical. There's just a slight shade to the left, the Prestige 70. It allows 70% of the light transmission through that glass, whereas glass itself is about 85 to 88%. Now, how do these films work, whether it's got metal in it or not? Simply, it's applied to the inside of the glass for the most part, and the design of either the IR rejecting film technology or the metallized film, it's reflecting away the solar radiation. In fact, it's reflecting it away before it becomes heat. And by increasing the percentage of reflection, and certainly reducing the amount of transmission that comes into the office environment, you can certainly make a major impact on the amount of energy needed to remove it, or the amount of heat, excessive heat that's coming in. There is a measure that's observed, and of that, some of it's drawn to the outside, some of it does come in. I'm going to move these slides along. And when we talk about the solar spectrum, we're talking about blocking or reducing everything from ultraviolet all the way through the infrared. we actually have some films that will help in the wintertime reflect radiant heat, man-made heat, if you will, back into the room, creating more of a low heat performance in addition to the sun control. A couple of definitions are important. We used to live with the term shading coefficient, which was a comparison of film on glass to 1/8-inch clear glass. 1/8-inch clear glass having a nominal number of 1.00. The industry, and that's not just window film, but the glazing industry in the world is moving more towards the term solar heat gain coefficient, or factor sometimes. And that's going to give you the overall performance of that window or glazing unit. The inverse of that would be the bottom definition, total solar energy rejected. So it's simple to understand, the lower the number, the better the performance. And with a highly reflective film, we can knock out as much as 75% of the heat that's coming in, or the potential of what could become heat, because, again, it actually isn't, the solar radiation doesn't become heat until it comes through, gets absorbed and re-radiated, manifests itself as heat. So if we can keep it out in the first place, then we're going to make the interior environment easier to manage. Another area that's very popular is skylights, because they bring in a lot of heat and glare. Sometimes the unintended consequence of trying to bring in more daylight is the heat that comes with it. And again, our films can do a good job of still maintaining a measure of light and vision to the outside overhead, but I'll make it more manageable by reducing the excessive heat or glare that's coming in overhead. One of the areas that really resonates well with the commercial environment is trying to manage the building as the sun moves around. Complaints start to show up wherever the sun is, and having a film on the glass, or better performing windows, if you will, using these technologies, can help manage that building's environment internally by reducing the impact of the external, i.e., in this case, the sunshine. This is actually a LEED certified building before we put our film on it. It was reskinned, but they found out they still had hot spots and some complaints. So that's the idea here, is even high performance glass could have some benefit here in terms of trying to mitigate the impact the sun's having on trying to run the building. Jump on the slide ahead so it doesn't go through. It's on slow move right now. Another aspect of what our films can do is help manage excessive glare. Complaints oftentimes with companies or tenants might do is, if they've got blinds, is pull the blinds. Of course, when you've got blinds pulled, you've lost your vision. And the benefit of films here is that we can help provide some solutions to some of the issues and still keep that intended vision to the outside. A lot of commercial high-rises, they're paying a premium for views. Downtown Toronto, they want to see the views, and blinds taken out of the way. And some films can help clean up the appearance. Not all buildings need that, but In this case, this was kind of hid a lot of tenants' changes, if you will, blinds open and closed or up and down and things like that. It provides a uniform appearance, and in this case it was actually done for self-control as well as security or privacy, because I want to protect the individuals in the building. And this building here is actually in Vancouver, with a highly reflective film on single-pane tinted glass. And then really, not only for the energy that they were able to reduce in terms of its expense, but also they like the uniform appearance that it brought out in the building. Now, the Prestige technology, this is the IR rejecting films, they're designed to be highly effective, yet still allowing more of the natural daylight to come through. So that was an inside look, and here's an exterior look, and you can see that you can still see in. It's not that shiny stuff. Glass itself can take on a reflective look, but when it doesn't have the backdrop of the sky, you've got two-way visibility. And this is pretty important for buildings, historic buildings, that can't change the look, must maintain the historic impression, or a retail environment where two-way visibility is critical to maintaining that open for business look. The Prestige has been very successful there, where it can help reduce the solar load, ultraviolet, and still maintain two-way visibility. And so rule of thumb estimates on the building environment or the envelope, for every 100 square feet of sunlit glass, we can knock out as much as 1 ton of air conditioning demand. And if you look at 20% of the building's energy usage goes into the air conditioning system, and we can save 10 to 30% of that. So net out that we can have an impact anywhere from 2 to 8% just on the bottom line of the energy, depending on the location of the building and the type of glass and what you pay for energy. Window films can pay for themselves. We often see paybacks in the area of 2 to 5 years. Some go longer. Again, it depends on type of product, the type of glass they have, the performance of that glass, location, utility. Some utilities, I think even Toronto Hydro has rebates for reducing kilowatts, peak load shedding. So there's a number of things can go into that return on investment. But one of the things that we're able to do, you can do a simple one right on our website, but just to get you an idea of what might be able to be saved, that really for a more detailed effort, we have what we call our e-film energy analysis to computer simulation. Takes into a lot of detail, even the configuration of the building, the type of glass, what you spend, the number of people in the office. So it gets pretty detailed, but it can give you some good insights as to the potential savings that you might earn with the application of 3M window film. And this is one of the printouts you get. I think it's a 30-page printout. But this will give you some ideas of what the different savings might be. It shows you the base case and then with window film.
Did you want to answer that, Jim? The question?
Yeah, I was just going to end.
Yes.
I know I looked down there, so I apologize if I've missed some questions here. The software through our local people, 3M Canada, in the window film area, would present that software to you or run the simulation for you as well, the e-film. Basically, it's a software that has our films loaded into it. It uses DOE principles, DOE 2 principles, but I could make sure, Vladimir, that let's say my counterpart in Canada connects with you, if that would be helpful.
And maybe you can just forward that information to me, Jim, and then I can forward that to everyone. Or, excellent. Yeah, if there's anyone's interested, please email me.
And we've got at least one of our Canadian people on here. See, Arnold Wong is on, so he'd be one of the contacts for you. So, but yeah, let's make sure we work through Alex on that.
Yes,
yeah. You can field all the questions, all the requests. One of the things we can also do is proof of technology, and this is simply doing a side-by-side comparison, where you do one office, we want to do the whole office with film, and another office next to it without film, and we can actually measure either BTUs or temperature. And with these data loggers we have, we just leave them hanging near the window, and they can record up to a couple of weeks, up to almost, I think, every 5-minute intervals, and kind of capture the differences and what the impact is that our film can make on the building environment. As we all know, conservation is good for our environment, and I think this is really where the Clinton Climate Initiative resonates and resides, if you will, is trying to focus on the 40 largest cities in the world, and then some, and trying to have them take energy measures to help reduce the carbon footprint, reduce the carbon emissions that are out there. And we certainly support that effort, and that's why we're partners with the Clinton Climate Initiative. And it's said that every reduction in operating costs can improve the value of commercial property. And I've seen numbers where they've said it's almost tenfold. For every dollar you save on the bottom line might actually increase the property's value by $10. And one of the things you can do is we can help achieve LEED credits. I mean, products by themselves don't get LEED credits, but we play in a couple of different areas, both energy and atmosphere, indoor environmental quality. So there is opportunities to help support goals if you're trying to achieve LEED credits. Scott, if I can answer your question at the end of this,
okay.
It might take a little more detail to go through that. Okay, thanks. And then I offered to just walk you through a little bit on what our security films can do. Because we work on focus on life safety, protection of property, and keeping operations moving ahead by maintaining the building's environment. And what our films are designed to do, especially the security films, is hold glass together. In different applications, there is concern for bomb blast mitigation, smash and grab force entry. Don't know if you have this issue, windstorm protection, but certainly in our southeastern quadrants of the U.S., hurricanes is a big issue. Seismic activity, I believe the west coast of Canada has some history and some detailed knowledge of that, as well as just general safety. When glass breaks, our film is designed to hold it together and make it safer. Simple design difference between sun control and a safety film is it's a thicker film, stronger adhesive, and we use a micro-layer technology that makes it even more tear resistant. So the impact will hold the glass together, and even to make a bigger hole in it, it's more resistant that way. And all of our films have a ultraviolet protection into it, inhibitor, that's not only going to protect things behind the window, but it's there really to protect our film from premature failure, if you will, or UV degradation. And if I can take just a minute, and Alex, if this works, I'm going to give this a shot. This is kind of a demonstration on our blast films. This is a...
I don't think it'll work there. I'll just hold on one...
Not going to work?
Just hold on one moment. And there you go.
Okay, this is unprotected glass, a blast environment of 4 psi. You can actually kind of see the blast coming across. And that's the damage that you can see from the bomb blast on unprotected glass. And obviously pretty severe. So move this on.
And then that was the second one.
The second one is right here?
Yeah, it just played, yeah.
This is side by side. This was what we call daylight application with our S400 film, clear 4 mil, and under those conditions you can see the dramatic difference of holding that glass together. And to give you a perspective on the blast, it was 4 psi, 4 pounds per square inch on the impact. Hurricane Andrew max was 1 psi. But obviously the difference is you're talking about split second here in a blast and several hours in a windstorm. And then for smash and grab, the design there is to hold that glass together. And sometimes if they determine they don't get in, we're just trying to slow them down and use it as a low-profile security measure where they expect the window to break and get in right away, and it slows them down. And we make some of those films with the sun control benefits as well, so you can capture 2 things together. Our warranties, most of our films come with a warranty that's 10 years or better, and it's, generally speaking, it's usually material and installation, so if it fails in year 8, which it won't, but if it did, we'd be out there replacing it at our cost. In terms of care and maintenance, which is a good question, often comes up, we suggest letting it bond to your glass for at least 30 days before you go clean it. But if you do need to clean it, and you might have a program where you clean your windows once or twice a year, and we're talking the inside, we're okay with ammonia-based cleaners. I know there's some out there that have prohibitions, but we build our films from the inside out, and ours are durable to take ammonia cleaners. We suggest don't use bristle brushes or things that could mar it. But, proper maintenance will get you long life out of the films. And here's a few case studies. Let's see what we do. This is Stelco Tower in Hamilton. This is with our low E35 amber. These are we did, I think, 3 sides of the building. Did not do the north side, that's because of the lack of solar load. And it was done over 15 years ago. Last I heard, it's still looking great. It was done, the original issues were, like I mentioned before, trying to maintain balance as the sun moved around and take care of some comfort complaints. But obviously it was going to have an impact on their air conditioning load and help justify the investment with some energy savings as well. Scott, let me come back to you at the end of this as well.
I was just going to type that too.
Okay. Another project that was done is Parkway Place, which I understand is just north of Toronto. Also done with Lily 35 amber film, which is a specular reflective film. The 35, I should probably say, allows 35% of the light in through the glass, so it's not a dark film. It is reflective, both solar and visibly reflective, so it can enhance the make it more uniform to the outside. And again, same issues, and maintain balance as the sun moved around and reduce complaints. And then also improve the energy efficiency by reducing the solar load that they'd have to air condition. And I should say, in some buildings, you might find that you ultimately aren't saving anything on energy because the air conditioning equipment in the building wasn't able to keep up. So with the addition or the installation or investment of our films, now it's actually maintaining the temperature they wanted. They're still running the air conditioning, like they did before, but now it's working. So really the cost avoidance of having to add more air conditioning, which cost and rent, that's where the savings would come from there. But to look at the energy bill before and after might not show any difference. It's just now the air conditioning system is actually functioning. Another case study, this one in Los Angeles, was Century Plaza Towers. 2 twin triangular buildings with single pane bronze glass. And we knocked this building out, 11,000 windows in just over 4 months. Now the payback period, again, you had large volumed business buildings, and we estimated, when we did the energy analysis for them, to be about, I think it was 1.5 years payback, and they came back and said they paid for it in less than 8 months. And they also got a utility rebate, and they took into account some other factors to bring it to an 8-month payback. But that's their study, not ours. So we always like it because we tend to be conservative in our estimates. And in this case, we don't mind that we were told we were not on top of it and not accurate because it came in better. So those are good surprises. And then another one closer to home in Toronto was TD Towers. And I think there's 5 buildings of which I think we've done work in 3 or 4 of them. One of them is shaded, so I think that's the reason not to be done there. But in this case, like I was mentioning, their air conditioning system couldn't keep up with the demand. They couldn't keep it as cool as they wanted it or the tenants wanted it. They couldn't upgrade their air conditioning system or bring in more power to run a bigger system. There was over 80,000 square feet. Again, LE35 amber was used. As you can see, it's used a lot in Canada. And the lower floors actually had a security pump put on there for improved security for some of the current concerns they have. But at the end of the day, what their results were is they lowered the complaints from tenants and improved efficiencies. I even believe they looked at replacing all the windows with IG units, insulated glass units, and my understanding is that the additional weight on the perimeter wasn't going to fit for what they wanted. But this has paid off well, and I think we're continually doing some more work in the building as they lease out more space. And, just like I mentioned Lee before, certainly there's areas that we can provide additional benefits as you're approaching to go after LEED certification in different areas, and this is kind of gives you an understanding of where we play and where we can help. But again, products don't get LEED credits, it's total systems and approach. I think we're there. Just a review of some of the reasons people will make investment in tram window films, from tenant comfort to energy savings to peak load shedding, and maintaining as much daylight as they can depending on the products, and going after LEED credits. With that, I'm done. I've got a couple of questions here to ask and answer.
Yes, yep. So the first one from Scott was he's experienced premature failure of some glazing, cracking or fogging after an interior film application. What considerations must be made to ensure that this does not happen, especially with IGUs?
That's a good question. For years we understand when we add film to glass, we're adding some temperature to the glass. And with our 45 years of experience, we know that there are certain, there's good fits, film and glass, and there's some to avoid. And we offer a warranty that covers the glass failure in terms of glass cracking. I mean, we don't get that too often, but we understand when the glass warms up, it's going to expand a little bit. So there's what we call the odd occasion where there is potential cracking, and we stand behind it because we understand, you can't pull the glazing and look at all the edges, but our incidence of failure is pretty small. A few out of 1,000, maybe 10 out of 1,000 max, and we stand behind it. On the issue of fogging, what you're talking about is seal failure, especially in the commercial environment. We know that windows, depending on how old they are, how well they were built, that there's going to be an experience of failure. And what we mean by that is, as you described, Scott, is the fogging of the window, where the seal has broken. And technically, we're confident and comfortable that film doesn't cause any of that. We're going to add temperature to the inboard light, but not enough to cause any seal failure, but we know it does happen. So what we try to do is look at the building, the history of the building, and if we can, find out who made the windows. There's a large commercial manufacturer here in the States called Binacon, and I imagine they do some work in Canada. And if it's a double sealed unit, meaning they've got a primary seal and a secondary seal around that IG unit, they have no prohibition, even for window films, because they're focusing on how well the unit is built. And we could certainly have more dialogue or discussion on that. But for us, we put up millions and millions of square feet of film, and the incidence of these kinds of failures has been relatively small. Stat, you had a question on security.
Yes. So,
unless the security glass film is clamped in the film.
So are we? Yeah. If we just want to read it out, are we correct to assume that unless the security blast film is clamped into the window frame, the window will pop out, or will it still occur?
Okay, and I think what Scott you're referring to is when we put film on glass, there's different systems. There's a daylight system, which is just putting film on the opening that sees daylight. It's not attached in any way. And then there's attachment systems where you can wet glaze or put a perimeter sealant around, a structural sealant around the perimeter, anchoring the film glass to the frame. Or there's flexible mechanical systems that we offer that will actually bond the two together or bridge the two together. Depending on what level of performance you're looking to achieve, a daylight may give you exactly what you're looking for. When you saw that video clip, that was a daylight application, and it would achieve what we call a 3B or better. 1 being the glass doesn't break, and 5 is catastrophic, where all the glass hits the back wall, and if you're in it, you're in the way. So it kind of comes down to what's the glass conditions, what's the level of performance you're looking to accomplish. So, and where you ask, will it pop out or fall in? When I did this glass testing 7 years ago, that first time, we've done it 4 or 5 times since then, the consultant and I are actually taking bets whether it falls in or falls out. But we understood what was going to happen. It was going to capture all that glass, hold it together, because what happens is a positive phase and there's an immediate negative phase, which draws that window or the glazing back. So I guess the simple thing is it comes down to what's the intended performance level you're looking to have, whether it's daylight or you need an attachment system.
Okay.
And with that,
There was,
Alex?
yes, there was a question by Ingrid. We will make this webinar available online. Would we be able to distribute it further? And we just wanted to make sure that that was okay with you. It is, that was your question, Ingrid, right? It's up above. It's towards, yeah, it's towards the top of the question, the chat section.
Oh yeah, I was looking at it, and I don't know if it's Jonalyn or Jonalyn. I apologize if
It was Ingrid, yes.
copies, and that's the same kind of question as Ingrid. Okay.
Yeah. So yes, we will. It will be available online, and you will be able to distribute it to your colleagues or networks.
And you could certainly, if that's also intended, share my contact information, and I can also get anybody that's interested, our Canadian counterparts who are out of our London office, but in Toronto every other day anyhow.
So yeah. So if anyone is
more than
interested,
happy to follow up.
yeah, if anyone's interested in following up on the Canadian partner, please contact me directly. You have my email address, and I will be forwarding an email shortly to discuss that. So please direct any questions to me. And then Vladimir is also going to be asking something. Yes. So yes, we will definitely provide an email address. And if anything is not, if you still want some more information, please email me back. Great. Is there anything else that anyone else would like to ask? Jim, is that okay with you?
It is okay.
Yeah,
I thank you all for your attendance.
Thank you. And thank you for coming too. And thank you for joining us today during your busy schedules. Again, if you if you want to learn more about the about 3M window films and like to learn more about the product discounts that are available through Clinton Climate Initiative, please contact myself. I will also be sending an email. Our next